let us look at what simple harmonic motion. Simple S.H.M of a simple pendulum. Want to look at the simple harmonic motion of a simple pendulum? All need that what? This is a pendulum bulb. Let me shift it here. So the pendulum bulb of length this is the bulb. So when the bulb is what? Is oscillating. The bulb is oscillating like this. Yes. And this is the what? The length of the thread. This is bulb. And this here we call it what? Length of the what? L here represent length of the what? Of the thread that is all the what? The bulb. And let us call this place what? Position A. Here we have origin O. Let's call this place what? B. This place what? C. And can observe that what? This is the ball at what? At rest. When the bulb is beginning to what? To oscillate to and fro, we will observe that what? There is a particular height here. The height of what? Of displacement of the what? Of the bulb, which is what? H. You can trace it to this side. This is the what? The height, which is what? H. Okay. And if this place is what? Is the length, original length of the what? Of the thread. And here is the what? Height. Then what will be this distance from here to what? Here. The distance here, we call it what? L minus H. Because this original length, here is 8. Subtract it. There will be L minus H. And here we have angle what? Theta. Where the bulb is what? Used to the maximum displacement or the angular difference of the what? Of oscillation. So from this now, and we can also observe that the flowing or the movement of the ball from 0 to A here, and this place we can call it what? Radius. Radius what? R. R. And then when a bulb or pendulum is undergo oscillation of a simple harmonic motion, the pendulum bulb here is undergo what we call law of conservation of what? Of energy. What is law of conservation of energy? So that what? The kinetic energy of the bulb is equal to the what? Potential what? Energy. So the bulb, the to and fro movement of the bulb of the pendulum is undergo what? Conservational law of what? Energy. So the it changed from kinetic energy to the potential what? Energy. At this point, the potential energy is maximum. When we get to this point A, the kinetic energy is what? Is maximum. Where potential energy is what? Is zero. So what? Ke equal to the what? Pe. What is Ke? Is half of mv square. Potential energy is what? mgh. Abi now? Good. And here again, we all know that what? Where velocity v is omega what? R. Let us substitute for what? Omega here. Velocity, you now have what? Half of mv, no, omega r everything square plus mgh. You now have half of what? M omega square, r square, and mgh. Yes. And from this expression, we can observe that what? We have r here, and this is r. Please let us find the what? The value of what? Of r from this sketch. We can now substitute for what? For r here, and then we find the value of h here. You now substitute for the what? For the h here. So to know the value of what? Of r, let us find the what? The value of r from this sketch. This is A, O, B, C. Yes, this place, let's call it what? D. Oh yeah, let us consider triangle what? A, C, D. I want to know this side. This what? This side. If I know this side, I will use this side and this side to know the what? R. Oh yeah, from triangle A, C, D. So triangle ACD, we have the triangle. It look like this. And here we have what? D. This place is A. Here we have C. This place is what? Is D. And the CD here is L minus H. That's the value here. And here we have what? L. This place is what? Is theta. And this place is what? Unknown. So by using Pythagoras theorem, let's call this place what? AD, Abi. By using what? By using Pythagoras theorem, it said that AC square is, this is right angle, AC square equal to what? AD square plus DC square. AD or plus CD, CD what? D square. What is AC? AC is L. We have L square. AD. AD is what? Unknown. Abi, we have our AD, which is what? Unknown. Plus, out of CD. CD is L minus H. Yeah, you now have AD square should be equal to the what? L square minus L minus H, everything what? Square. The AD square will be equal to the what? L square minus, if you solve this, it will give us what? L square plus 2LH minus H square. So if we open the bracket, you now have what? AD square should be what? L square minus L square plus 2LH minus H square. This cancel each other. Distance AD square will be equal to the what? 2LH minus H square. That's for the what? Distance AD. The next one is what? Similarly, AOD this is AOD. And here we have H, AOD, AOD, DO is H, AO is what? R. Let us know the what? The AD by Pythagoras theorem too. By what? Pythagoras theorem. Abi now? So the hypotenuse square equal to the what? Opposite square plus adjacent what? Square. Hypotenuse is what? Is R square. Opposite is what? AD plus H. You know, square. So you have what? AD square equal to the what? R square minus H. AD square what? R square minus what? Minus H. Abi? Yes. You can observe that what? Here, AD square is what? 2LH minus H square. And here too, AD square is what? R square minus what? H square. You now say what? Therefore, AD square for the first triangle equal to the what? AD square for the second what? Triangle. You will equate these two together. What's the first one here? Oh yeah, we have two what? 2LH minus H square. What is the second one? Equal to what? R square minus H square. Don't forget that what? We are looking for what? R. Yes, you will rearrange this. This expression, let's take this inside. You have 2LH minus H square plus H square equal to the what? R square. This will cancel each other. You will now have what? R square equal to the what? 2LH. Abi, this is the value for what? From there, let us continue. We have half of what? M omega square R square equal to the what? MGH. So what is our R here? We have what? R square equal to the what? 2LH. Let us put it here. We have half of mass omega square R. R square is now what? 2LH equal to the what? MGH. Yes, here now. This H cancel this H. This M cancel this M. We are left with what? Half of omega square. No. This one cancel this two. We now have what? Omega square L equal to the what? G E. And again, omega. Recall that omega square equal to the what? 2. No. Omega equal to the what? 2 pi over what? Over t. Let's substitute for the omega here. You will now have what? 2 pi over t L square equal to the what? G. By we have 4 pi square t square L equal to what? G. Let us make T square, no, cross multiply first. 4 pi square L equal to the what? T square G. So you can now have T square equal to the what? 4 pi square L over what? Over G. Find the square. You have square root of what? 4 pi square L over what? Over G. So the period T equal to the what? 2 pi into what? L over what? Over G. This is the formula for period